Alright, this is part 2 of our graphing and mathematical models. This is the example problem that we are going to look at in order to understand how these 4 targets work on over here. So let us move on over. Those are our notes from before, and let us take a look at a data table. So first things first, I see this data table, and right away I think, okay, standard form means independent variable will be on the left-hand side, dependent variable is going to be on the right-hand side. So that's where I clue in. And if this makes any sense, we take a look at it's like number of regular seasons game played. Wait a minute, can I control that? Can I say after 5 games what's going to be happening, or after 3 games, or after 1 game what is going to be happening? And that is something I can directly control. I can take data at any point in time in terms of regular season games played. So that makes sense. I am controlling that, which makes that the independent variable. The dependent variable is going to be something that is affected by that, and we look at total number of interceptions. Well, that is dependent on what game we're on. How many games have we played? So after 4 games, it's 12. After 6 games, it's 17. Can I guess what's going to be happening later? No, I can't necessarily say what game is it. Or I need to say what game is it in order to have the number of interceptions. So that matches up our dependent or our independent and dependent variables there. I'm going to zoom out, and I have this nifty graph paper right on over here, and I'm going to start our standards with graphing. So independent variable should be plotted on the x-axis, so I'm going to go on over here and write down number of regular season games played. So that is the variable, and of course you put parentheses in the units, which is going to be games. On the y-axis, we're going to do the same thing and plot or write down number of total interceptions measured in interceptions on the y-axis. The next biggest thing with graphing, this is something that a lot of people screw up, you need to start your graph at 0, 0. 100% of the time, make sure you are starting at 0, 0. A lot of people screw this up. They forget to auto scale if they're using a computer, or they always like to say, okay, this first dash is 1. No, that is always 0, 0. Next thing to note about graphing, each one of these dashed lines is going to be the same increment. So in this case, on our x-axis with the number of regular season games played, I see that I only have to plot 7 as my highest number, so I can actually go up by 1. So 1, 2, 3, 4, 5, 6, 7. You'll notice that it is equal increments from there. Total interceptions, we take a look at that, and we'll notice that we have a lot to work with. The problem is if I go up by 1s, you'll notice that I won't be able to get up to 20. And in this case, I count them 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm going to say it's about 10, and I know if I go up by 2s, I'd get up to 20, which is my maximum value. So I'm going to do that. It says 2, 4, 6, 8. It means that it would be 10, 12, 14, 16, 18, 20. And again, if you're struggling with this, just kind of mark it out. Make sure that they're equal increments. You don't necessarily need graph paper, but we're going to make this a little bit easier for us. And then once you do that, all you got to do is start plotting points. So at 2, we would be at 8. At 4, we're at 12. At 6, we are at 17. So that's 12, 14, 16, 17. And at 7, we are at 20. And in math, once you have a bunch of points, you can start to look at, is this a straight line? And for the most part, we look at this, we can say, yeah, that looks like a straight line. So in order to draw in a best fit line, what we need to do is we need to use a straight edge, put it over the points. I'm clicking buttons as I go, but that's okay. I'm going to put it over the points and try to the best of my ability on this computer screen to draw in a straight line. As long as that line goes in between the points, you can see it misses this first point here, hits the second, hits the third, misses, or kind of hits the fourth. I'm going to say it's a pretty good best fit line. So we have this, and now the thing that we need to create is the mathematical model. So going on over here, I'm going to say y equals mx plus b is the standard that I like to follow. You could say dependent variable equals m times the independent variable plus the y-intercept. That's fine. but I think just memorizing y and x could be just as helpful. So y in this case is going to be number of total interceptions. So that is not a unit, that is a variable. We plug that in. There should be no unit associated with that. It is saying I want to plug in a number there. M is going to be the slope. So in this case, we're going to have to calculate the slope. The way to calculate a slope is looking at your best fit line and finding 2 points that you can kind of look at to take a look at, or to take your slope from. So I find that one looks like it intersects. I really like that point. That is going to be 4, 12. And another point that it looks like it hits, let's use this one right up here. That looks pretty good. That's a standard that we can look at. That is going to be 7, 20. So those are our 2 points, and as we learned from our notes, M is going to be the change in y over the change in x, rise over run. Change in y is going to be, in this case, 20, but in science, there is no such thing as naked numbers. That is 20-something, so that should be 20, oh boy, I think we jumped. I'm sorry about that. That's 20 interceptions minus our initial y value, which will be 12 interceptions. Our x values, the change in x is going to be 7 games minus 4 games. And so we could do the math there. 20 minus 12 is 8 interceptions, and we have it per 3 games. In science, 8/3 doesn't make that much sense, so the way that I want to think about this is actually as a decimal. So the way that we have this, 3 goes into 8 twice, gives us 2/3 remaining, so we have 2.3, I'm sorry, that would be 2.6. It's 2/3 remaining. 2.67 interceptions per game. So that is what M equals. We can plug that in here, 2.67 interceptions per game, times X, which X is the number of regular season games. And we are going to add this to our y-intercept, and we go on over to our graph. We note that our y-intercept, I don't know why my screen's being so touchy right now, sorry about that. Our y-intercept is right there. It looks like it's a little bit above our first value, which is 2, but not necessarily 3 yet. So I'm going to say 2.5 in this case. And that, of course, has a unit with it. The unit for the y-intercept should always be what is the unit on our y-axis. So this is our mathematical model. Now, the most important thing about a mathematical model is we can now make predictions. From this mathematical model, I can look here and I could say, you know what? What if we played 16 games? I can see how many total interceptions I would have by just plugging that in. Or better yet, what if, or what game will I be at when I have 25 interceptions? Notice how we didn't take any data on this, but if this trend continues, we could start making predictions. Now, we would only want to plug in one of these numbers at the same time, so we could say, oh, at 16 games, we'd plug that in. You actually do the calculations, you can come up with how many interceptions you have. Have we played 16 games yet? No, not from our data, but if the trend continues, we can follow that out. So that is one of the most important parts of that. So we have our mathematical model. The next biggest thing is meaning of the slope. So meanings is really important. So meaning of, and we're going to look at the slope. Slope is the easiest because you literally just say what the slope is. It is 2.67 interceptions per game. And I look at this and I have to think about this and I have to say, oh, so this is the meaning of this. This is the total amount of interceptions I will throw in a game. So this is the, what we can maybe say, the average interceptions per game. And again, depending on how you take the data, maybe this is Jay Cutler's average interceptions per game. You can start to kind of tailor it more towards how you took the data. So that is the meaning of the slope. The meaning of the y-intercept, as we discussed in the last video, is taking a look and saying, well, this is when I have played 0 regular season games. So I go back here and I say I'm at 0 regular season games, and I have, for some reason, some interceptions. So I'm going to just think about this. If 0 regular season games I have 2.5 interceptions. And now you got to start making sense of this. How can you have interceptions if you played 0 games? And the way that you could maybe say the meaning of this is saying, wait a minute, this is maybe the preseason interceptions? And you kind of look at it as like, how is there a 0.5? So maybe our data is a little bit off. But this is trying to tell us something about what happened before you played any games, so maybe you talk about preseasons. So these are 2 possible answers. We would have to have a little bit more information on the actual, how we took the data in order to pull this out. So we have just looked at an example. Let's kind of move on over here. We have looked at an example that allowed us to see the independent and dependent variables, correctly label and plot a graph, know the mathematical model, and understand that importance. We really saw that. And last but not least, meaning of the y-intercept and slope. So this wraps it up. Tomorrow we will do a worksheet based right on this. Be ready for that. Thank you for listening. Have a great night.